So today we are going to be discussing special angles. So there's certain angles that come up a lot in trigonometry, and they have to do, of course, it's trig, deal with triangles. So the triangles that we deal with a lot are 45, 45, 90, and 30, 60, 90. So if you remember from geometry, when they're in the ratio 1, 1, radical 2, that means the first one's 45 here. So the side opposite is 1, and they're in the ratio 1, 1, radical 2. So no matter the size, we could put like a 1x plus 1x, and no matter what, that ratio will always hold true when you have a 45, 45, 90 right triangle. So it's 45, 45, 90 because you know this is 90, and the two 45s all add up to 180. So the side opposite 45 is 1. The side opposite 45 is 1, and the side opposite the 90 is radical 2. So using that information, we're going to be doing like the sine of 45. So let's just talk about that. So the sine of 45 degrees is opposite over hypotenuse, so it's 1 over radical 2. Now, this is something special we need to go over a little bit more, but we do not like when there's a radical in the denominator. So we do what's called rationalizing it. Now, you were supposed to talk about this when you were in geometry, but if you didn't, you simply multiply the bottom by the radical that's there. So that's radical 2. So I multiply the top and the bottom by radical 2, and I'm left with radical 2 over these two multiplied together is radical 4. So it's radical 2 over 2. That's rationalizing that denominator. We'll go over that a little bit clearer, but what you have to remember is that the sine of 45 is radical 2 over 2. The cosine of 45 is, if this is 45, it doesn't matter which one you choose, 1 over radical 2 again. And rationalize, that's radical 2 over 2. So the cosine of 45 and the sine of 45 are the same thing. And then the tangent of 45 is 1 over 1, which is 1. So we're going to put that in a little chart on the bottom. And, you're going to have to remember, here's the chart down here. So the next one was 30, 60, 90. This is 30 degrees. This is 90, so this one has to be 60 because they all have to add up to 180. So 30 degrees here, the side opposite 30 degrees is 1. The side opposite 60 is radical 3, and the side opposite the 90, the right angle is 2. Okay? And these things have to be put together in we put them together in a chart to help you remember. If you don't remember how to convert radians to degrees to radians, remember you would multiply 30 times pi over 180, and we would leave these in terms of pi because we really do like it that way better most of the time. So those are those three. The 30 degrees is the same as pi over 6. So the sine of 30 degrees, if you put sine of 30 degrees in your calculator, you would get 0.5 or a half. And the reason that is, this is 30 degrees right here. Sine of 30 degrees is opposite over hypotenuse, so that's 1/2. 60 degrees, or pi over 3, the sine of pi over 3, or 60, is opposite over hypotenuse. So if we're looking at the 60 degrees, this is now the opposite. So it would be radical 3 over 2. We already went over what the sine of 45 is. That was up there, so I'm just going to throw that in. Cosine of 30 degrees. Looking at this one again, this is 30 degrees. Cosine is adjacent over hypotenuse, so that's radical 3 over 2. We know this one already. We did that. And the cosine of 60 degrees, the cosine of 60 degrees, this is 60, so it's adjacent 1 over 2. Interestingly enough, you do have to memorize this, but if you look at it closely, you see it's on the bottoms is always 2's for sine and cosine, and then it goes 1, 2, 3, and then it goes 3, 2, 1. So making the chart is pretty easy, so that'll help you remember those. The other thing we have to do is tangent. Remember, tangent is opposite over hypotenuse. Opposite over adjacent. So we know that 45 was 1. We did that one above there. And then if you look over here, the tangent of 30 degrees is opposite over adjacent. So that is 1 over radical 3. We have to rationalize that. So it's radical 3 over radical 9, which is 3. And then this one right here is just plain old radical 3 over 1. So we're going to discuss rationalizing a little bit more, but what you have to remember is the values in the end. Okay, we're not going to go too deep into the rationalizing. It's more, can you remember these 3 values, in this chart here? So these are exact values of each one of these. So if I put it in my calculator, this is like 0.707, it goes on forever. But we have to remember that. So doing exact value combines what we did yesterday and today. So we want to find the exact value of the sine of 240. Well, that's nothing like we know. I don't know what that is. If I put in my calculator, it's something weird. So the sine of 240, what we need to do is figure out what is an equivalent value. So what we do the box, line, box. So where is 240? Well, 240 is somewhere in this quadrant. So ASTC, that's tangent is the only thing that's positive, so sine must be negative. 240, what is the reference angle here? Well, I want to basically, if this is a whole angle 240, I only want this little section. I need to cut out the 180. So I need to find my reference angle there. So it's negative the sine of 60. Well, if you look on the other side of this paper, negative the sine of 60, so it would be radical 3 over 2. So in the next one, we have to convert and take it from there. Oh, no, we don't. We're moving down here. Okay, so cosine of negative 30. So negative 30 is right here. So that's in quadrant 4. So we know cosine is positive in quadrant 4. So it's the same as positive, the cosine. And what's the reference angle for negative 30? Well, it's just 30. So the cosine of 30 is also radical 3 over 2. But in this case, it's positive because we're in quadrant 4 over here. All right, the tangent of 7 pi over 6. So if we do that, we have to convert 7 pi over 6 and then try it out. Okay, the tangent of 7 pi over 6 is the same as the tangent of 210. So this is in quadrant over here, so it's in quadrant 3. So tangent is positive. So it's positive, the tangent. And what's the reference angle? Again, in quadrant 3, we have to do 180. We have to do 210 minus 180. So that would be 30. Same as the positive, the tangent of 30, and the tangent of 30 is radical 3 over 3. So this is exactly what we were doing yesterday, but now we have to do it with, we have to actually get the value that it's equal to. Okay, so if we want to find the secant, we'll do a little reciprocal functions here. If we want to find the secant of 3 pi over 4, convert this, and we get 135. And what we need to do, same idea, secant helps us, kind of messes with us a little bit. So we have to do, well, secant, positive or negative, so this is 135. So secant of 135 it's positive. It's negative because it's sine is positive here, and sine's reciprocal is cosecant. So it's negative secant, and then the reference angle. Well, with the reference angle, remember, we do the whole angle is 180 all the way to the x-axis, but I need to cut out that 135, so it's 180 minus 135, which is 45. So it's negative the secant of 45. So basically we just flip the cosine of 45. So it's secant of that would be 1 over negative the cosine of 45. So remember, secant is the reciprocal of cosine, so it's equal to this. So all I have to do is flip it. So it's cosine is radical 2 over 2, so I just flip it and it becomes negative 2 over radical 2. Again, rationalizing this bad boy, 2. We get negative 2 radical 2 over 2. Those cancel out, and it's just negative radical 2. The next one here, cosecant of 225. This is going to be similar to what we did up there. Cosecant in quadrant 3 here is negative. Cosecant 225, so the reference angle is also 45 degrees. You subtract 180 from it. So it's 1 over the negative of the sine of 45. So it's the same thing as above here. And it's the same answer here. It's because it's 1 over sine is the same as 1 over cosine of 45. So it's negative radical 2. So now the cotangent of 5 pi over 3 is, or negative 5 pi over 3 is the same as the cotangent of negative 300. So you figure that, you know, all the way over here to right about here is your negative 300. This one right here, this is your reference angle. So, oh wait, we're in quadrant 1. So since all of them are positive in quadrant 1, you know that the cotangent is going to be positive there. And the cotangent of negative 300 is the same as the reference angle here, would take us to 360, or negative 360 if you want to go there. We need 60 more to get there. So the reference angle is positive 60. So the cotangent of 60, well, that's 1 over the tangent of 60. So it's 1 over radical 3, and rationalized, that's radical 3 over 3. We'll go over this a little bit more, so don't get too frustrated over it. If you can get to this part, we're pretty happy. Have a good day.